talk about some probability today. Okay, remember, probability is a measure of the likelihood that a specific event will occur. So remember, an event is our desired outcome. Okay, so the thing that we want to happen. Probabilities have values between 0 and 1. An event that is impossible, meaning can't happen, will have a probability of 0. An event that is certain or will absolutely happen has a probability of 1. Okay. So how we calculate our probability, okay, is by using a ratio. We've been using those often this year. Okay, so we're going to create another ratio between our favorable outcomes to our total outcomes. So this is where I'm going to use my color pencils here. So the probability of an event, again, what we want to happen, is the number of favorable outcomes over the number of total outcomes. And again, an outcome is what can happen in our experiment. So for example, if you're flipping a coin, you could flip a heads or you could flip a tails. Those would be outcomes. What do you get out of the activity you are doing? Okay. So let's do some practice here. Again, this is asking for fraction, decimal, and percent. Okay. So for A, it's looking for our odd numbers within this spinner. Okay. So we're going to go ahead, let's create our fraction. Okay. In total, there are 1, 2, 3, 4, 5, 6, 7, 8, 9, 10 total possible outcomes we can have. So our denominator is going to be 10. Now we want odd numbers only. So 1, 3, 5, 7, and 9. Those are odd. So we have a total possible chance of getting an odd number 1, 2, 3, 4, 5 times. So we're going to go ahead and reduce that down, and that's going to be 1/2. Now 1/2 as a percent is 50%. Again, we move our decimal 3 places to the left to create our decimal. And again, you do not have to have the 0 at the end. Okay, look at our next one, a multiple of 4. So a multiple of 4 is like skip counting. 4, 8, 12, 16. Again, we haven't changed our total here, so our total amount of outcomes is 10, so our denominator is still 10. And we have 2 possible outcomes that are multiples. So in this case, this would reduce down to 1/5. Again, we're dividing our numerator and denominator by 2. Now there are a couple ways you can do this for converting. Okay, you can divide your numerator by your denominator. So we could take this and go 1 divided by 5, and that gives us 0.2, so that would give us our decimal. To change it into our percent, we would go ahead and move it over 2 times to the left, 1, 2. So that would tell us that this is 20%. Right? Let's look at C, a prime number, meaning numbers that only have factors of 1 and itself. So, excuse me. In this case, again, we still have total outcomes is 10. So, for a prime number, okay, 2, 3, 5, and 7, because all these other ones have other factors. So we have 4 total that are prime. We can reduce this by 2. Again, if you need to see that, I like to use the giant one. So that would be 2/5. Now the other way you can do this is to make an equivalent fraction out of 100 to get your percent. Okay, again, to get your decimal, you would take your numerator, divide it by your denominator, and this would tell us it is 4/10. Again, 2 times over 1, 2 would tell us this is 40%. Last but not least, okay, even or greater than 5. So again, we still have 10 total outcomes. Denominator is 10. Now, even numbers. We have 1, 2 that are less than 5. And then all the numbers that are greater than 5 also count. So 1, 2, 3, 4, 5, 6, 7. So we have 7 outcomes that are even or greater than 5. Okay. This one I'll show you how to go to your percent. Okay. So 7/10, I'm going to multiply it by a giant 1 of 10, which is 70 over 100, which tells us this is 70%. As we saw when we were in our percent unit, our decimal is behind the 0, and when we move it 2 times to the left, so our decimal would be 0.70 or just 0.7. Okay. Now, we can have different situations. So if you look here, we're going to look at the word acceleration. Okay, what's the probability that we pull the letter R? If we just had these all separated on sheets with each letter, what's the probability we would pick the letter R? Okay, well, first we need to start with the fact of how many total letters we have. So 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12 total outcomes. So our denominator for all of these is going to be 12. Right? Now, of all of these letters, what we want to pull is an R. So how many R's do we have? Well, we only have 1. So as a fraction, this would be 1/12. Okay? Create your decimal. Again, numerator divided by denominator. So 1 divided by 12. Okay, it's going to give us a repeating decimal, so we're going to go ahead and round that. So we're going to say approximately 0.083 and then put a line over it. If we move this back 2 times to create our percent, 1, 2, that would put our decimal between the 8 and the 3. and that would be our percent. Okay, now let's look at the probability of pulling the letter C. So in total, there are 12 letters. Of those 12, 2 of them are C. Okay, again, we could reduce that by 2, which would be 1/6. And I put that in the wrong color, I apologize. Again, we're going to go ahead and divide this out. So 1 divided by 6. Again, we get a repeating decimal. So 0.16 with a line, because that 6 is going to keep repeating. Again, move it twice to the right to create our percent. So this would be 16.6 with a line percent. All right, 2 more. So probability not a vowel. Again, 12 total. A vowel, A, E, I, O, U. So let's see, not a vowel. 1, 2, 3, 4, 5, 6. So there are 6 total letters that are not a vowel, which of course would reduce down to 1/2, which we know is 0.5 and 50%. And then our last example, probability we pull an L, an R, or an A. Again, denominator is 12. How many total L's, R's, and A's are there? There's 1, 2, 3, and 4. So 4 in total. We can reduce that down by 4 to 1/3. Again, divide out. 1 divided by 3. And that gives us, again, a repeating decimal. So 0.33 with a line. And again, move it twice to the right. So our percentage would be 33.3 with a line, saying it repeats, and then our percent.